So what did you learn?
We learnt a lot about protein structure, the importance of hydrogen bonds.
We learned a lot about GFP.
About GFP itself, yeah.
What skills did you get?
Teamwork, good team.
Teamwork, yeah. I suppose responsibility.
Yeah. And the whole just following instructions as well kind of thing, but I suppose I
Did
don't
you do
know.
that very well?
No, we weren't that good at that. I'm just going to say we did it anyway.
What else did we learn?
How to work on your own, I suppose. Just we're giving a task and we weren't really told how to do it. We were just told to do it. We had to learn really ourselves.
Trial and error.
Trial and error.
Yeah.
Tell me about building the side chains.
It was the easiest part of making the model, I'd imagine. It was just starting off.
Once you got used to it,
Yeah, once you can fire them away.
Once you knew how to make, after about making 3 or something, there was something that were 20 of them involved, and once you have to make 3, you just find it interesting.
Because we got a video from the second year practical upon which to base our own side chains.
The tryptophan was actually grand, but it was really big. And Jonathan made the only one. There was only one of them in it. But obviously alanine was good one.
It was confusing, wasn't it?
Yeah, it was tricky enough.
Find out the amount of each amino acid in the actual model.
We got the amino acid sequence under the GFP. We just counted them all and then just kind of got our pieces and then just added them all up on Excel, and we got our numbers that way. And of course, then we had to do the generic amino acids as well.
How many generic amino acids did you make?
What was it?
238.
We just put them in strands of 10 to start on it.
Yeah.
And just to get them in.
And modify them for the length of the particular
Each
strand.
strand just added on or took off however many generic amino acids we needed.
Well, while you're making it, you learn a lot about the different structure of the protein, specific qualities of different side chains. Basically, since you're making a protein from the ground up, you learn everything about it, right up to the actual structure.
Tell me about bamboo sticks in the water.
Building the temporary stand for the moment anyway, just because we weren't sure of the diameter. Out of bamboo sticks and water bottles. It was just the easiest thing at the time. It was the first, we went through a few things, but it was just seemed the best idea at the time.
Easy to get as well, I suppose.
Yeah, very easy to get.
Why did you use water bottles?
Well, we could change. We didn't know the dimensions first of all, so we could move them around to the actual size of the beta gun.
The later we got into building the structure, we found out that it just got too heavy for the bamboo sticks, and we came in some days and the model we tipped over, so we kind of needed to get our change then. But up to that point, it was very good. He was probably our best option.
We found the diameter barrel when we connected the strands together with the hydrogen bonds. With the actual structure itself was quite wide when we started out. The whole thing contracted really well when we added on the hydrogen bonds, especially inter-strand bonds. In fact, we were able to take away a load of water bottles as well, which helped. We made the whole thing smaller and a little bit more sturdy. And we had all the hydrogen bonds on and everything was connected, and we know that was the diameter. So we were able to use that to build a more permanent structure out of wood from the measures we got from that.
Once we had the dimensions for the permanent base, we bought both the materials in a DIY shop, and the chief technical biochem officer went about building the base with our help.
When we transferred it from the temporary to the permanent stand, we had 4 poles sticking out of the permanent stand. We found 4 weak spots with the temporary base. Once we lifted up all the water bottles that were left, put it on the stand, we found our 4 points that we needed to attach to the poles, and then with the hydrogen bond and stuff, we used cable ties to attach the strands to each pole. And once we started doing that, the actual stand that we saw on the PDB viewer was starting to become more recognisable on the structure. We started coming together then.
We got the sequence of GFP from a protein database, which we could break down into the various loops, beta strands and alpha helix. We had this sheet with the hydrogen bonds as well, so we could put the hydrogen bonds into the alpha helix, making it the correct shape. The central pole for the base as well was the correct diameter for the alpha helix, so the helix itself fit around it very snugly and tightly. It was only supported in the end by 1 cable tie. The alpha helix is connected to the rest of the model by 2 loops. One loop coming out of the top, which joins onto a beta strand. The other loop comes out of the bottom, joining onto another beta strand. These are all held together by hydrogen bonds.
Originally we built the beta strands with the side chains attached, but when we were building the beta barrel itself, we had to take the side chains off just because it was really difficult to see what we were doing. It was simpler just with the side chains off and just simple linear beta strands. And so at that point we started adding on the loops and adding on the hydrogen bonds between the loops and the beta strands.
When we were building the loops, we we added on the side chains then straight away to the loops, and added on the hydrogen bonds to the loops. This made them stronger. The loops are then added onto the beta strands.
Tell me about the green ribbons.
Well, one of the last things we did was add on the green ribbons to the beta strands, and we did that just to highlight the beta barrel and the orientation of the beta strands.
Once the green ribbons were added on, the next step was to add on the side chains, and once we did this, the model started taking its shape and the structure of GFP became very apparent.
So at the very end we decided to put on orange ribbons onto the loops, just so you could distinguish between the connections between the beta strands.
I think it would be used a lot, the GFP model, in the biochemistry department. It would be a very useful teaching aid.
You could point out all the different parts of a protein itself, like the amino acids, the beta strands, the loops, the actual structure, and the hydrogen bonds holding it together, each individual side chain.
I'll teach students as well about like each structure of the side chain stuff that you just, for like exams, if we had that from first year, I know it a lot better than I would now. Now we have a fixed protocol. If you want to build a GFP model, it's there.
It's pretty simple, concise, pretty cheap as well. So any science department should be able to undertake this same project.
Mainly taught myself, and I did pretty well. Except there were a few mistakes, but that I made that I have just recently cleared up.
Tell me about your original feelings about the project.
I was very surprised. It was the last thing I thought I'd be doing, making a model. I thought it'd be just pure lab work.
Instead of spending all the time in the lab, like, it was a lot better, I thought.
Previous work in a lab was 30-40 students on a demonstrator, maybe 3 or 4 demonstrators. This project there was three of us, and I'd say we dealt with 10 different demonstrators, so it was a very personal experience. From week to week we had different goals, which would eventually add up to our final conclusion or goal result.
And I always think it's easier as well working to a goal as well, instead of like been doing it out of your own time. I think it's a lot easier when someone sets you a task, you have to do it by a certain date. I just think it's a lot easier.
It's a lot easier working with separate tasks towards a goal than just doing one thing for the sake of it and then another thing which is completely separate.
Working for 2 months towards a goal, when we went in with our final 1 ml sample, we got a positive result. Usually in a lab I didn't really care, just wanted to go in, get it done, get out. This time I suppose put a lot of hard work into it. The result meant a lot to me.
I honestly don't think we'd do I wouldn't do anything differently. Because we learned so much from making our mistakes and kind of just going over them again. That's kind of what made us learn, I think. It's great to actually say something in biochemistry, I suppose, for once.
What makes cancer tenacious? The moon rules the fluids, including the inner juices of human beings, that which assimilates and feeds the body. So the crab feeds his astral brain, assimilating and distributing all he receives slowly until it becomes a part of him.
Ergo, GFP is cool.
Yeah.